All right, welcome back to Genius. So in this section, let's talk about what a computer system is. And I know that most of you already know what a computer system is. So, but we beg your pardon because this is beginners friendly. All right, all our courses are beginners friendly. So we also accommodate people who don't really know what a computer system is. So please, you can actually skip this class. All you have to do is just go and take the test. All right. Take the test, and if you're able to pass the test, you go on to the next one. So for any session you think that it is too beginner friendly for you, please, you can just go to the next session. Just write the test. Once you pass the test, that means you understand what was taught in that particular session. So you can go to the next class. Okay. So now, let's take a look at what a computer system is, okay? Most of us might not really understand what a computer system is. I know that you know that your phone is a computer system, you know that your laptop is a computer system, but there are other things that you need to understand about a computer system, okay? So a computer system refers to the complete setup that enables digital computing and processing tasks. So anything at all that enables digital computing and processing of tasks is a computer. All right. Computer is not just necessarily your laptop or your phone. All right. Anything at all that enables digital computing and processing tasks is a computer. Okay. It comprises of hardware, software, the users of the computer, and network components that work together to perform computing operations. Okay. So it comprises of hardware, the software, users, and the network components that work together to perform computing operations. So computer is not just the big computer you're seeing with you. The software, the users, all this is make up a computer system. All right. Any system that can actually enable you to perform digital computing and processing of tasks is a computer. All right. Anything at all. So now, what are the components of a computer? We have the hardware. And when it comes to the hardware, we have different now the hardware is the physical parts of a computer, the one you can see and touch. All right. You can actually touch your keyboard, you can touch your mouse, you can touch your monitor, stuff like that. Okay. So the first type of hardware we talk about is the input devices. Now, the input devices, remember, your computer will take data from you, process the data, and give it to you back. Okay. So how do you give the computer the data you want it to process? So input devices are the devices you use to give the computer the data you want it to process. So you use input devices like keyboard for typing, all right? You type into the computer and the computer will process the whatever you're typing. You can use mouse to click on icons. You actually telling the computer what you want it to do for you. So keyboard is an input device, mouse is an input device. Scanner, you can also use scanner to scan documents. All right, when you use scanner to scan documents, your computer will actually get it. You can also use microphones to, just like now, I am speaking to the computer right now to record this video. All right, so it's using the microphone and the camera. You can also use cameras to capture images and videos. All right. So these are input devices. And as computer gets broader, okay, and gets more improved, more input devices will actually come up. Okay. There will be more input devices later on because for any particular type of computer, there have to be an input device for it. Okay. So your CCTV or your CCTV cameras, they use camera to actually capture images and videos. Then when they do that, the computer that is in that particular system will process that data and do whatever it has been programmed to do with the data. Okay, so input devices are keyboard, mouse, scanner, microphone, and camera. You can actually research for more because this might not just, I think joystick is one of them. So you can actually research for more input devices. Okay, so we are still on the hardware, which is the physical parts of a computer. We also have the processing unit. Okay, so the central processing unit is actually the brain of the computer. It performs the calculations and control tasks. So CPU is actually the brain of the computer. The processing unit comprises of the CPU. It also comprises of the control unit. All right, these are the things we'll be seeing how these things actually work. The control unit is what directs the operations. Remember, as a developer, you will write instructions you want the computer to perform. So it is the control unit that will be checking one or two things to direct the operations. When you say 2 plus 2, it is the control unit that will check which operation do you want to perform, and then it will direct the operations to whoever is supposed to perform that operation. Then arithmetic and logic unit handles the calculation and the logic of the system. All right. When it comes to doing calculation, mathematical calculations, logical calculations, it is arithmetic logic unit that does it. We are going to see more of all these things, how they actually perform their job. All right. Every part that we are mentioning here has a way of performing their jobs. Okay. We also have some things we call registers and cache. Registers and cache, they are actually memory devices. Okay, they are actually used to store data. But you get to understand when we start talking about when we start going deeper into this, okay, you understand that registers are memory that are very closer to the CPU, okay, or they are closer to the processor. Let me put it that way. They are closer to the processor because your memory is actually far. So the thing is this: your CPU or your processor needs to fetch data from your memory. The memory in your hard disk is very far. All right. In as much as they are in the same location, you will not. Yes, when we say far, don't worry, we'll explain what we mean by being far. Okay. So these days, they now created registers and cards that are memories that are very close to the microprocessor than the hard drive. Don't worry, you'll get to understand that. But registers and cache are very fast memory for immediate data access. They are closer to the microprocessor. All right. They are closer than the hard drive. Your hard drive is far from the microprocessor. And then one thing is this: when computers try to fetch instructions or try to fetch data, they travel down to your hard drive and then come back to the processor to process those things. Don't worry, we are going to be taking a look at that. You understand how these things work. So registers and cache are fast memory that are closer to the processor. And basically, this processing unit, you can actually call it the processor, the microprocessor. Okay, that is basically what we call a microprocessor. Okay, that's the CPU in general, but the real name, the best name you can actually call it is actually a microprocessor or a processor. Okay, so components of a computer system, say we see on hardware. All right, we have the memory and the storage devices. Okay, we have the RAM. All right, the random access memory. This one is where when your computer is actually running. Okay, your applications and data. Let's say now you click like right now my slide is my slide is actually running. So this is a software. Okay, as soon as I clicked on this software and get it started, everything about this software will be loaded into the RAM. The RAM is actually temporary and volatile. Okay, but this is where your processor gets this is where your software are being loaded. Any software that is currently running on your system are being loaded in your RAM, and that is where everything gets started. So, but don't worry, we'll talk about how all these things work. So this is how that is why you're having this course, to understand how all these things work. So whenever we get to memory and storage devices, we're going to talk about how these things work. Okay. You also talk of the ROM, read-only memory. They are very permanent and they are only read-only memory. You don't write to them. Okay, we are going to explain what we mean by all these things. RAM is random access memory. They are temporary, and this is where all your software, your running software, your instructions that have been executed are actually present in your RAM. Okay, and when the system goes off, your RAM also goes off. Everything there goes off. That is why you need to store them in hard drive. So your ROM, you cannot write to them. They are permanent and they are read only. You can only read from them. You have the hard drive. It can be HDD or SSD. Okay, so for long-term data storage, we're still going to all these things we are talking about. You're going to understand memory, because even as a developer, as a computer programmer, you need to understand how memory works. Okay, so I'm going to be discussing all these things, and you get to understand them better. Okay, but your hard drive is for long-term data storage. You already know, most of you know this. We also have the flash drives, the SD cards. Okay, These are for portable data storage. You can actually remove, you know what your SD card actually is. So you can actually use it. You can store data in that, and you can actually use it in several other devices. Okay. So we also have output devices. Your monitor is, or your display unit is actually used to display. When you use the input device to give data to the computer will now process it. The CPU, all right, the processor, the microprocessor, or the processor, or the CPU will process the data and then give it back to you, and it will be displayed using your output devices. It could be your monitor, it could be your printers, it could be your speakers, all right, it could be your projectors. Okay, then we also have the motherboard, which is the main circuit board connecting every component. All the components of a computer are connected together using the motherboard. All right. Now we also have the power supply unit. This power supply unit converts the electricity. Now, when you plug your system, all right, when you plug your system to electricity, this power supply unit will convert the electricity to the kind of power that your computer can use. All right, we are going to see all these things. We are going to see more of all these things later. You're going to understand how your computer actually works. Okay. So another component of the computer system is your software. All right. Software are a set of instructions that tell the hardware what to do. You as a computer programmer, your job is to tell the computer what to do. So you'll be the one to write these instructions. You will tell the computer, I want you to add 2 plus 2 for me. I want you to play this video for me. I want you to do this. I want you to do that. Okay, you as a developer, as a software programmer, as a computer programmer, you're the one writing the instructions. Okay, so when you write these instructions, the software will now, you're actually telling the hardware what to do. Then the hardware will perform it. Especially the microprocessor will do the computation. Okay. So when it comes to software, we have different kinds of software. We have system software, and these system softwares are the ones that come with your computer. You're not the one that install them. They actually come with your computer. Your operating system, whether you're using Android or Windows or Linux, or Mac OS, you did not install them yourself. They came, okay, when the designer or the producer of your computer, they actually installed all these things before they are follow come. Let me put it that way. So these are the operating system manages the hardware and software. We'll talk about operating system in details too. You're going to understand how operating system works. Okay. We also have the device drivers. Now, device drivers allow hardware and operating system to communicate. Now, your operating system does not communicate with the hardware directly. It communicates with the device drivers. Have you ever noticed that sometimes when you go to install, when you go to maybe flash your laptop or your computer, those hardware engineers that are repairing your computer for you, they will say they want to drive your system. Now, when they say they want to drive your system, what they're trying to do is that they are trying to install these device drivers. All right. We will also talk about these device drivers. Okay. So your operating system will communicate with your device drivers. Then your device drivers will now communicate with your hardware. So every operating system, most of the software that you have, all right, have their different device drivers. Okay. So more is coming on that in later chapters. We also have the utility softwares. They perform maintenance tasks, especially like antivirus and disk cleanup. So these are system software. They actually come, you are not the one that install most of this. You don't install them. Okay. So we also have application software. Now, this is the one you and I write. As a software programmer, this is the one you'll be creating. You'll be creating these ones, your TikTok application, your bank system application, all those software, you're the one that will create them. So we call them application software because you are your Microsoft Word, your Chrome, your Photoshop, you install those ones. So these are programs that they perform specific tasks. And my differentiation between application software and system software is that system software, you don't install them. You cannot even uninstall system software. But application software, you're the one that install them. So those applications that you install, the application software, those applications that you actually develop, your mobile applications you develop, and all those ones, these are the application software. We also have programming software. These are tools used to write code. Now, any user can actually use application software, but programming software is basically used by computer programmers, people who write programs, write software, all right, tools like Visual Studio Code, compilers, and interpreters. Don't worry, you're going to understand what all these things mean later on, because we will also be, in this course, you'll be learning computer programming, you'll be learning C and C++ and Python. You'll be learning these programming languages, okay? So let's quickly take a look at types of computer. We have personal computers, the desktop and the laptops, your mobile phone. These are personal computers. They are small, all right, compared to servers. Now, servers are used basically for networks. Now, these servers, they provide services to other systems over a network. Don't worry, you're going to understand servers more when we talk about web programming, because we'll also talk about it. We'll talk about web programming in this course too, okay? Mainframes are large systems for bulk data processing. You and I cannot afford these ones, the servers, the mainframes. No, these are afforded by big companies, all right? Supercomputers, they're extremely powerful for complex scientific calculations. Every computer is designed for a particular reason, okay? So we have the personal computers, your servers, the mainframes, and supercomputers. We also have embedded computers, embedded systems. These are computers within devices, your microwave ovens, your cars, your washing machine, okay? These are computers in your electronic systems, all right? Your television, all right? These are computers inside them. So these are different kinds of computers. So in your remote, in your television, in your cars, we have embedded systems in them. Okay, so they are also computers, but they are smaller. All right. So let me take you through a little history for a better perspective of how computers have actually grown. Okay, so it wasn't until 1940 that the first computers showed their faces. One of the first computers was the one called ENIAC, the Electronic Numerical Integrator and Calculator. It was a general purpose electronic computer that could be reprogrammed for different tasks. Okay, this might not be necessary, but it's also good that you understand the journey of computers. And even before the 1940s, there were small devices that were used for calculations. But it wasn't until 1940 that something that looks very real like the computers we use today came up, okay? It was designed and built in 1943 to 1945. It was a 2-year project at the University of Pennsylvania. I don't know how to pronounce this, but it was by Presper Eckert and his colleagues, all right? So they designed this computer and built it. It was a 2-year project. So it contained more than 17,000 vacuum tubes. And the truth is that I don't even know what vacuum tubes are. Maybe people from electrical and electronics engineering, they can actually understand what this thing means. Since I started studying computer science and stuff, I have not bothered to actually go and check what vacuum tubes are. But the thing is this, these are what we are used to create the first computers. It was approximately 8 feet high. The first computer was 8 feet high. It was more than 100 feet wide. Just imagine a whole room. So the first computer will be as big as a very big room. And it was about 3 feet deep, about 300 square feet of floor space. So it is more than even a room, the first computer. But today, you and you can even wear a computer on your wrist as a wristwatch, or even in an embedded system. But the first computer was this big. It weighed 30 tons. Imagine, it weighed 30 tons. And it required 140 kilowatts to operate a large amount of electricity power, okay? Now, 40 years later, things got better. And about 40 years later, many computer companies and computers later, in the early 1980s, the Burroughs A-series was born. Each board contained 50 or more integrated circuit packages. It is no longer 17,000 vacuum tubes. It is now 50 or more integrated circuit packages. Instead of 300 square feet, it took around 50 to 60 square feet, all right? And instead of 30 tons, it weighed around 1 ton. You can see the improvement, all right? You can see the drastic improvement, okay? And instead of 140 kilowatts, it required only 25 kilowatts to operate. So this was around 40 years, that's in 1980, okay? 30 years later, all right, we now have today's computer, the desktop, the laptops, and our smartphones. So their relative weights and energy requirements have decreased so enormously, and the speed at which they process information has also increased. So the speed at which they process information, those days, 40 years, 70 years back, all right, the speed of computer, the speed that they process information was slow, but right now they are very fast. We estimate that the computing power in smartphones today, that is how fast we can compute with a smartphone, is more than 4 million times the computing power of the first ENIAC. So your smartphone, even though it is smaller, all right, than the ENIAC, the first one that almost the size was as big as a room, all right, your smartphone was over 4 million times faster. Your smartphone is over 4 million times faster than the first computer that was created. So these days, the integrated circuit packages that comprise modern digital computers, okay, they have also seen phenomenal improvement. So I remember 30 years back, integrated circuit packages came. Now the first microprocessor, the Intel 4004 in 1971, contained 2,300 transistors and operated at 106 kilohertz. That's the speed of it, okay? And it contained 23,000 transistors. So the first microprocessor, which is the Intel 4004 in 1971. So basically, the microprocessor is actually the engine, which is the CPU, is the engine of the computer, okay? Now, by 1992, all right, 20 years later or thereabout, those numbers have jumped to 3.1 million transistors. In 1971, the first microprocessor contained 2,300 transistors, but 20 years later, it now contains over 3.1 million transistors and at a frequency of 66 megahertz, okay, on the Intel Pentium microprocessor, and increase in both parameters of a factor of about 1,000. So you can see the speed is 66 megahertz. Remember, the first one is 106 kilohertz. Okay, so this one is faster and it contains more transistors, 3.1 million transistors against 2,300 transistors. And the thing is that the more transistors you have, the better microprocessor you can actually develop. Don't worry, we'll talk about that later on. So today's microprocessor contains almost 5 billion transistors and they can operate at upwards of 4 gigahertz. You can go and check the properties of your computer. You will see that most of your computers can run at 1.7 gigahertz, 4.4 gigahertz, and thereabout. Just go and check. So this is another increase in both parameters of about a factor of 1,000. So the computer keep on improving. It kept on improving, and today we are here. Okay. So before we close, let's understand something. There are two ideas I want you guys to understand. The first idea is this. All computers, no matter how big the computer is, or no matter how small the computer is, the biggest and the smallest, the fastest and the slowest, the most expensive and the cheapest, they are all capable of computing exactly the same things if they are given enough time and enough memory. You know, sometimes you go to buy a laptop and they will tell you that this laptop is costlier. It is costlier because it is faster and it has enough memory. Your iPhone is actually costlier than all these Android phones that you're actually buying because your iPhone contains more memory. So all these things make up, all these things will add up to the price of the computer. Don't worry, you're going to see more about this later on. The memory size, how fast is the memory, and how fast is the computer itself. So now all computers, whether they are slow, whether they are fast, whether they are expensive, whether they are cheap, they all do the same thing, exactly the same thing, if you give them enough time and enough memory. The only difference here is that anything a fast computer can do, a slow computer can also do it. The only thing is that a fast computer will do it faster and a slow computer can do it slower. Now, have you ever, sometimes you are using a phone, most times some of these old phones, all right, Your iPhone is faster, or this new Samsung or these new phones, they are faster than those old phones. Okay, the thing is this, those old phones can still do the same thing your new phones can do. The only thing is that they will do it slowly. They will do it slower than the new phones. So every computer can do the same thing as long as you give them enough time and enough memory. All right. If let's say now both of us we are to go to from Lagos to Abuja. All right. If you take a flight, all right, and I go by road, you'll be there. You'll get there earlier than I would do. But the thing is that we will all get there. If you go by a bus and I go by maybe a bicycle, we will still get there. But the difference is that how long does it take us to get there? So for every computer, if you give them enough time and enough memory, both of them will perform the same operation. So the slow computer just does it more slowly, all right? And a more expensive computer cannot figure out something that a cheaper computer is unable to figure, as long as the cheaper computer can access enough memory. So mostly, all right, most computers are costlier because they are faster, their processor is faster, all right, and their memory is also faster. They have enough memory. So you can see that basically your computer processor and your computer memory somehow determines the cost of your computer. You're going to see why it is so, all right? So all computers can do exactly the same things. Some computers can do things faster, but none can do more than any other, all right? So that is the first one I think I want you to understand. The second one is this. We describe our problems in English, okay? We developers, we programmers, all right? We describe the problems we want this computer to solve. We describe it in something that looks like English, all right? Even your algorithm are described in English, but they are not converted. So they are English or other spoken language, all right? They are described we describe our problems we want the computer to solve in English or other language spoken by people. Now, yeah, these problems are solved by electrons running around inside the computer. In the next two sections, we're going to be talking, we'll show you how the problems you write, the code that you write in English, how these problems are going to be solved by electrons. We are going to show you how, in the next two sections, you're going to see that. So we describe our problems in English, but yet, English or any other language, but yet these problems are solved by electrons running around inside a computer. Remember that your computers are just electrical components, your transistors, your logic gates, these are just electrical components. So if you open your computer, you see all the wires running around everywhere, okay? So the problems that we want the computer to solve are solved by electrons. So it is necessary to transform our problem from language of humans to the voltages that influence the flow of electrons. So as a computer programmer, when you write these problems in English or any other language, all right, there is necessity, all right, to convert these things to voltages that the computer understand. Don't worry, we are going to show you more on this. So this transformation is really a sequence of systematic transformation. Like I said, in the next two sections, we'll talk about that. So they are developed and improved they have been developed and they improve over the years. Now, which combine to give the computer the ability to carry out what appear to be some very complicated tasks. So you write your problems in English as a computer programmer, but these problems are solved. All right, when you say 2 plus 2, you write it in English or any other language, but that 2 plus 2 are being processed, or the problem will be solved by electrons. Then you will not get the answer as 4. We are going to show you how these things work, okay? In the next two sessions, you'll get that. So you can see that this is really interesting already. So in reality, these tasks are very simple and straightforward. I promise you that in the next two sessions, we are going to show you that, okay? So thank you very much. Please, if you don't understand something, you get confused in any way, please reach out to us. We're always available, okay? Make sure you do your test. Make sure you do your assignment if there is any, and I'll see you in the next session. Thank you very much and have a great day.